Negative 3m plus 10. Add.
The opposite of 6m, I got to get rid of this. So the opposite of that is negative 6m. So subtract 6m over here, and you get
-4.
What's the opposite of positive 6? Okay, so
-2.
4 minus 6. How are you going to put this in?
Why?
Yeah, divide negative 15.
So it's -2 over 15.
No.
Two.
Actually, each question is worth about 2,000. However, you could argue that since there are different difficulty levels on the ACT, some questions are easy, some are medium, some are hard. If you mess up the easy one, you could say that's worth even more because you had to get that one right. So if you messed up an easy one, you could say that's like a $10,000 mistake because you had to get that one right. This is pretty easy. This is medium. This is medium. This is medium. Questions on one. Rewrite them with the same base. You have to ask yourself, what's the common root? What do 16 and 64 have in common? You could have said 4 or 2. If you said 2, that would also work. You would say 2 to the 8th or 6th or something like that. I'd have to figure it out. I'd have to look. So you would just take your calculator. You'd say 2 to the 5th. Nope, it's 2 to the 6th. So you would say 2 to the 6th. 2 to the 6th times that. And you would say 2 to the 4th, I think, over here. Yeah. Please tell me you got it. In fact, quick poll.
Cancel out 2 off the top.
See what you say. Passing secret code messages back and forth, huh?
Easy. Come on, man. Come on.
Well, I know. Don't say that because literally, when y'all did this on the You know, not the discovery, but my discovery.
But I'm 3% of it.
What percent would one person be in this
How many people in the class?
in this classroom?
How many people? How many folks took the test?
How many people took the test? That's the question.
That's the question, Jay. That's the question.
I think 16 took it. So you're actually,
Who got the mouth?
Kevon, you're actually about 6.25%. Doesn't make sense. About 17, But judging by how quiet it was, I'm going to guess that somehow you must.
It wasn't hard. Yeah, do all that. I just looked at the end. Made them end for it's the only one.
So you just look at the ends, because all.
End 3 is the only one. Everything else was, and then look at the ends. You can tell, 2 from 9, that's 7. So you can cancel out the rest of that. Put C, D, and 1.
That's good. Okay.
That's so easy.
Just don't miss it on the ACT, please. Or on the end of course test.
It's only on there, not mine. It's only on there. None of it. That one on there. That one on there.
None of
that
it.
one on there.
None of it.
Nah, that was on there.
None of it.
None of it.
None of it.
No.
Take a look at the notes. 10, 9, 8, 7.
What paper is this? Hold on, so what's this?
What? Y'all got 3 sheets today. I like that idea. That's a good idea.
We got stuff with these or something?
Alright. You could if you want to.
Oh, that's just the work. We missed the work.
Alright, now, sorry if it's a little bit crooked, by the way. You're going to be feeling off the whole time. Logarithms. A few quick points to kind of help conceptualize this for you before I just start giving you steps. So, we've done exponential. You're pretty good at exponential. You have 2 options, exponential growth or exponential decay. 2 different options there. You look at the base to tell if it's growth or decay. And we didn't have any negatives, right? So no negatives. It's always going to be the range is always going to be greater than 0. The domain is always what? All real numbers, because it goes right and left forever. Alright, the opposite or the inverse of exponential is logarithmic. It's the exact same thing you'll see today. We're just going to be flipping back and forth between the 2 because they are opposite operations, just like addition and subtraction. You can look at the graph and you can kind of tell that they are opposites. They both have a curve. This one opens up that way. This one opens up in the opposite quadrant. They're inverse graphs also. To read this, you say log. You got 2 kind of weird words here that you have to use. You're going to say base 2, log base 2, and then you say of 8. So log base 2 of 8 equals x. That's how you read that. And so what this is asking is, what power do you raise 2 in order to get 8? So 2 to the something equals 8. You can probably guess that. You can probably figure it out. Yeah. 2 to the 3rd. Yes, I do. I have the list and I've sent them down. Yes, sir. Yes, sir. So here's what he did. He went to my mailbox and he said, Coach Matisse doesn't have his list. He doesn't know which juniors to send down. But what he doesn't know is this.
Oh, that's a new thing you take out. Camera. You know about the camera.
And then let me make one more point. Yeah, he didn't know about the camera. Listen, let me make one more point. If you want to try to catch me, doing something wrong, don't call and say, I didn't pick up the sheet that wasn't in my mailbox when I got here this morning.
You need to call.
Call him. We're gonna call him. Stay away from the camera.
Tony, that's fine actually if you want to sit there, because then that lets Terrence slide down. That's fine. Okay.
Teamwork.
I don't mind that. Anyways, all of that is irrelevant.
So sum 2 to the sum power equal 8.
Yes, sir.
I see the 3.
What does this mean? This means 10.
Log base 10.
So sum equals what?
To the second. Log base 10 equals log base 2.
What?
That's too easy.
That's too much talk.
Log base 10 of 100 equals x.
It's two.
Log base 4 equals 64, and x equals 30. Equals 3. To me, that's wrong. That's right, right? No, say it right. OT said it like that.
So these ones, they're kind of easy.
Log base B equals A.
Log base
You just forgot, you skipped over one part.
Hold up. It was M.
Log base B
Oh, yeah.
Of M.
Now what we're going to do is we're going to convert it into, now it's a lot easier to do these in exponential form. Okay, so some of them will not be so easy. This is really easy. You can kind of figure it out. Some of them will not be so easy. So what we're going to do is convert them into exponential form, because we're pretty good at that. You know, if the bases are 16 and 64, we can say, what's the common root? 4, and go from there. So in this case, we're going to rewrite this in exponential form, and it's actually very simple. This is what you need to, so right now, just draw some stars and fairies and footballs around this. So draw, you know, whatever you love, draw some of that around it. This is the most important part right here. And here's what it says. It says the base is the base, so leave the base the base. So the base here is B. The rest of this stuff, you just switch places. That's all you do. So n crosses over and becomes your exponent. M crosses over, and that's what it's equal to. So what you're left with is b to the n equals m. You can switch back and forth between exponential and logarithmic equations in this way. Okay, can we try this one? What's the base?
X to the Y
to the Z
To the Z
equals Y.
equals Y.
I got this. I got it. K to P. K to Q.
So that didn't trick you that it was backwards?
No, can't give me.
Okay. All right, take your paper and flip it over. Hard work.
Okay.
It's possible to reverse the process. You can also go the other way. So here's what that looks like. Start off and write log, which is short for what? Yeah, 2 words basically, log and rhythm. You know both of them, logarithm, and that's the noun version. The adjectival version is logarithmic. Yeah, adjectival. You want me to look it up?
No.
Adjectival.
Clause, phrase, prepositional phrase. Adjectival. Definition of adjectival. Adjective.
A part of speech that modifies a noun or pronoun.
So,
I'm gonna fail you just because you asked me that. Oh, no.
so the exact same idea applies here. Why does this work? Because they're opposite, just like addition and subtraction, just like multiplication and division.
So this is the opposite of it.
Logarithmic and exponential equations are the exact opposite.
So what radical come in this? They gotta do it.
It's a good question, because a square root is kind of the opposite of an exponent. Logarithmic is kind of like a third opposite, which doesn't really make sense.
So all of them go together.
They kind of all are in the same family. But if you look at the graph of the radical and the logarithmic, can you see how they're kind of similar? So you can see how they're related. They're kind of similar there. It's like a cousin. Can you write this in log form? Log base x of z. Yeah, good. Now we're not adding or subtracting anything. Y'all being goofy. Set it equal to x. Y'all need to take a deep breath. Chill out. Calm down a little bit now. So first you're going to convert it to exponential form. First you set it equal to x. You say equals x. Then you convert it to exponential form. So what's the base? The base is 1/2. What's the exponent? And that equals. How you gonna do this? It's like the one we were doing last week. What's the common base?
No, he recorded the lesson.
Always record. 2 to the what equals 1/2?
Negative 2, right? Negative 2.
No, that would give you 4.
Negative 1/2. You said negative 4?
It's negative 1.
I'm gonna say this is 1. When you flip it, you just you have to reciprocal of 2.
Right.
1 over 2.
Right.
I know what I'm talking about. See, the one that the base of those stupid.
2 to the what equals 1 over 16? Yes. Good, Lorena. You can definitely still use guess and check here to make sure that you're getting that exactly right.
Positive 4.
There you go. Pretty straightforward. All right, can you tell me how to do this one? Raise your hand. Okay, Latrell.
Alright, we're gonna use who? So we got the scroll with 2 laws. No,
Your base.
equals x. That's fine. So we got scroll with 2. But then you to x to the power of x equals 4.
You don't know.
Alright. Good. Make a base equal, right?
What's the base? What's the common root?
Can we get
2.
2 to the second power?
Okay, so the other one's easy. 2 to the what equals radical 2? Try it in your calculator. If you have an idea, test it. If you have an idea, test it in your calculator. 2 to the what equals radical 2? 2 to the first is just 2. 2 squared is 4.
Don't worry about it. 0.5. 0.5? What we talking about? The square root of 5 is 1 point. So you gotta put up to 1/2. 2 to the 0.5 equals 5.
Yeah.
What are we doing?
Raise
I
I just did this.
This is 1.4.
Oh, okay.
On my credit.
Oh, okay. Say you we got.
In my right.
Oh, okay. I got it.
So it's 0.5.
Good one hand.
For argument, I don't even know what they're talking. That speed is going on the city.
You have to change it to 1/2.
Honestly, you can use either one. You can use 0.5 or 1/2.
X equals 4.
Divide both sides by... Questions? Equals x, convert to exponential form, solve.
Why can't your base be a negative?
Why can't your base be a negative number? It just doesn't happen. No, here's why. Do you remember imaginary numbers? You can't graph an imaginary number, so that's why you can't have a negative base. You can graph an imaginary number, but it has to be on the imaginary coordinate plane, which we're not talking about yet. Cachette.
How would we negative 2?
How do you get negative 2? Good question. Who said negative 2 right there? No, it wasn't me.
You did good.
I just wrote too quick.
Man, I'll just put something crazy in. I think y'all were telling me what's right. Somebody said negative 2. Okay, thank you for catching that mistake. Any other questions? All right, the rest of the worksheets are your homework for tonight. You can go ahead and get started. You got about 15 minutes to knock it out. Yep.
I tried. Say you tried.
Let's go.